G'day folks, it's Rob here, and in today's clip we're going to be running through how a radial flow settler works. It's that little blue jobby there, the best place to locate it within your system, and also a few tips on how to size it so you can make it as efficient as possible at removing solids from your system. Radial flow settlers have been used around the world for years in wastewater treatment plants because they are a very efficient method at removing solids from water columns, and that makes them an ideal little jobby for us to knock together and pop in our own aquaponic systems. Now, some folks call these radial flow settlers swirl filters. While they do look similar from the outside, the mechanics in removing solids from the water are very different. Just to let you folks know that I have filmed a clip looking at how this little jobby was put together, and that will be uploaded very soon to YouTube, so you can check out that link down in the description once it's posted to the channel. Now I'll grab the camera and we'll have a bit of a gander at how this little jobby works. So to run through how these filters work, we really do need to start in the fish tank here. So what we have in the center is a solids lifting outlet. And down the bottom, what happens is the solids are picked up along with the water. They're taken up to the top of the solids lifting outlet, travels along the pipe there, and then out through the side wall of the tank. Now the pipework then travels down. I've got a valve in mind just to make cleaning a little bit easier. And that pipe runs through to another sweeping bend that redirects the pipe vertically inside a stilling well, and it terminates towards the top of the filter, and you may actually be able to see a few small bits of solid come through there. Now this stilling well has a larger volume of water in it, so the entering water slows down in velocity slightly, and it is then redirected downwards towards the base of the stilling well. There, that water with the solids in it is introduced into a larger volume of water, so the velocity slows further again, and the majority of the solids will then precipitate out of the water column and settle on the base of the vessel there. In a small little DIY settler setup like this, the water then exits at the top of the vessel through the side wall into a pipe, where it then moves out to the next component within the system. The water exits the main chamber over a weir that runs the circumference of the vessel itself. Now this larger collection area of the weir helps to slow the velocity further, allowing more solids to fall from suspension out of the water column and collect on the base of the vessel. That water circulates around the weir until it exits through a pipe in the side of the vessel, just like the DIY ones we make,